Welcome to 10.2 Graphing Cosine Functions. In this video, we're going to go over the comparison between sine functions being graphed and answered, and comparing them to cosines and how they would be answered. In slide 2, we first start by taking a look at the actual graphing of our cosine function. Notice one of the largest differences that we see here is that on the y-axis, we actually have the y-intercept occurring at 0, 1, when with a sine function, it was actually occurring at the origin itself. So in most cases, whenever we are going to be graphing the cosine function, we will be reaching the maximum amplitude in any one of these graphs. Now, it may change from graph to graph depending on what the amplitude is, but as long as the equation is positive, it would be hitting the maximum amplitude. In the case that the actual equation is negative, it would then be reaching the minimum on the y-axis. You can also see that there has been a shift as well, off by pi over 2. As we start taking a look at the properties of a cosine function, I've actually gone ahead and compared it to the sine function. Now, in both cases, you can see that the domain is the same, in which it is all real numbers. It is also the same when we are taking a look at the range of numbers. So we are going to be going still from a -1 minimum to a +1 minimum. And it would be inclusive because we do see solid dots occurring at the minimums and maximums. There is a difference between sine and cosine in the fact that cosine is an even function, while our sine function is an odd function, meaning in an even function, there is a reflection across the y-axis. As you can see here, you can see that there is a reflection across that y-axis. As it increases on the right-hand side, it goes up to the 1. We are seeing the reflection occur onto quadrant 2, which would mean that this is even. If it reflected, as in sine, over the origin into the third quadrant, this would mean that it would be odd. Now, the cosine function is the same as the sine function in the fact that the period is still 2 pi. What will occur, though, is that you will have different sets of x-intercepts and y-intercepts. Although the period is still occurring and the distance in between the points is the same, you will still run into a different set of x and y-intercepts. Now, in point 6, we can see that the maximum value and minimum value, yes, they are the same, but the difference would occur at where they are occurring. Notice it's still occurring from -infinity to +infinity, but the numbers at which they are occurring would be slightly different. In slide 3, we are here taking a look at the vocabulary. Now, for the vocabulary itself, it is the same as all the same vocabulary that was used to describe the sine functions. Our amplitude is still talking about the distance from the midline going towards the maximum height and the minimum height. Our interval is describing from the beginning to the end of one cycle of our cosine function. The period is the horizontal length of one repeating pattern. Your horizontal shift is the shift towards the left or right or a horizontal movement. Your vertical shift is the distance moved up or down. And your interval is still the horizontal starting point and ending point of one complete period of a cyclical trig function. As we start taking a look at our sinusoid equation, notice here Everything is the same as the sine function that we had before. The only real difference is, rather than there being a sine, we would actually see cosine in its place. Now, in order to help reduce the amount of confusion between both the sine and cosine equations, I went ahead and scratched out the sine and inserted cosine. Everything would still remain the same, where A, B, C, and D are still constants, but we are still going to have one major factor, which is A and B still cannot be 0. In slide 5, we are still going over what a midline is. Keep in mind, the midline is the middle between the maximum and the minimum, and that midline is the halfway point in between the two of them. Our amplitude remains the same. Now, whether we are looking at the sine or cosine, you can easily see that it will always be the absolute value of A in both scenarios. In slide 7, we also go over a period. Notice the same thing occurs within sine and in cosine functions. It will always be 2 pi over b in both scenarios. Now, on slide 8, you can easily see that we are still using all of the same equations that we were previously using, and nothing has changed there. The amplitude is still determined by figuring the absolute value of A. The period is still 2 pi over b. Our phase shift, or our horizontal shift, is negative c over b. And the length of the subinterval is calculated by figuring the period divided by 4. Now, if you're also looking for the vertical shift, the vertical shift would be equal to d. Let's take a look at a couple sample problems. We first begin with 2 cosine of x. As we did before, we're going to go ahead and we're going to take a look at a. In this case, a is 2, and the absolute value of 2 is 2. Our period is 2 pi over b, so we go ahead, write 2 pi, our b is 1, which means our answer is going to be 2 pi. Oftentimes you can do the period and the subintervals back to back. The answer from your period would be divided by 4. So our period in this case would be 2 pi, and we would go ahead and divide by 4. This would simplify to pi over 2. We go ahead and work on the phase shift. Now in this case, we do not have a c, which means we are looking at 0 divided by 1, which means our phase shift is 0. And since there is no midline, d would be equal to 0. Let's take a look at our next problem. In this next problem, we have negative cosine of 2x. Now, in this case, what is happening is that we are seeing a reflection of the original parent function for the cosine function. We go ahead, take a look at the amplitude, which would be a positive 1. Remember, this is the absolute value of A. We're going to grab 2 pi and divide it by b, which is 2, which will simplify 2 pi. We go ahead, take care of our subinterval. Pi divided by 4 would simplify 2 pi divided by 4. We take a look at the phase shift. In this case, we do not have a c, which means 0 divided by, in this case, 2. We go ahead, solve that out. Our answer is 0. Our midline, once again, is 0 since we do not have a d. As we get to the next problem, now you can start seeing that the letter C is approaching on that right side of the parentheses. Oftentimes, you may want to go ahead and work the problem in a way where it makes sense for you. If you need to go ahead and write A, B, and C, I would highly suggest that you go ahead and do so. Now the absolute value of A is 3. Your period is going to be 2 pi over B, or over 2, which would leave you with pi. Your subinterval would be pi over 4. In this case, your phase shift would be a negative c. Now, your c is already negative, which means that we are going to be looking at a pi over 2 as our answer. Our midline in this case will still remain as 0 because we do not have a d value. Go ahead to the next question. Here we have our amplitude being 1/2. Our period is 2 pi over b, which is 4 in this case. So we will simplify to pi over 2. Our subinterval, which is pi over 2, divided by 4, would go ahead and leave us with pi over 8 as our simplified answer. We go ahead, take care of our phase shift. A negative c would be a negative 3 pi over b, which is 4. Once again, we have no midline here, which means 0 is our answer. We start approaching our last two questions, and you can see that all 4 letters are present within each one of these two equations. The first thing that we would solve is the amplitude. Amplitude would be 2 for this equation. Our period would be 2 pi over 4, or pi over 2. Our subinterval would be pi over 2 divided by 4, which is pi over 8. Our phase shift is negative c over b, so we're going to have a negative 3 pi over 4. In this case, we do have a midline. As you can see, that positive 1 would be the midline. Our last question, we go ahead and take a look at absolute value of a, which in this case would be 3. We're looking at 2 pi over b, which is 1/2. This goes ahead and simplifies to 4 pi. 4 pi divided by 4 will give us pi for our subinterval. Our phase shift would be negative c. Notice we already have a negative in that negative pi, which means we will end up with pi over b, which is 1/2. This will give us a final answer of 2 pi. We go ahead to check out the midline, and the midline in this case would be a positive 2. Let's go ahead and take a look at slide 10. Here we begin working with actually graphing the problem itself. Once again, if you're not 100% sure about what the equation is looking like and how the letters kind of confer with the equation you're looking at, I would suggest going ahead and writing the sinusoid function. Notice f of x is equal to a cosine of bx plus c plus d. In this case, the first things that you will be able to determine is that, notice there is no d in this equation, which means our midline is 0, and we also do not have a c, which later on, as we begin plugging in, you will end up realizing that the negative c over b will go ahead and give us 0 as well, and that would be mainly for the phase shift. Let's begin with the very beginning, which is the amplitude. The amplitude is the absolute value of a. which in this case would be 2. Your period is going to be 2 pi over b, which is 2 pi over 1, which is 2 pi. The subinterval is the period divided by 4. We're going to grab that period, which is 2 pi, divide by 4, which would leave us with pi over 2. Our phase shift is negative c over b. In this case, we do not have a c, which means this is 0 over 1, or 0 for the phase shift. And when we're looking at the range, easiest way to get this answer would be to take a look at the midline. And what you will do is you will subtract your amplitude for the minimum, and you will add the amplitude to the midline for the maximum value. So this right here would be a range of -2 to +2. As we begin with our actual graph, the first thing that you're going to want to do is find where that midline is. And you're going to draw that midline by going ahead and drawing a dotted line going across your midline. You want to mark your maximum and minimum. In this case, maximum would be 2, minimum would be -2. Our subinterval is going to tell us exactly what is the distance between every single one of these points that we're going to start off with. In this case, our subinterval is pi over 2. So we're going to go ahead and label each one pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Now our phase shift is going to tell us exactly where we're going to start. So in this case, since we are starting with at the 0 mark from our phase shift, we have to go ahead and keep 2 things in mind. First, is the equation positive or negative? In this case, it is negative, so it will be a reflection of our cosine function. The next thing would be the fact that we're looking at the cosine means that in this case, we would be looking and starting at the minimum of our entire equation, which means we would begin with -2 at the 0 mark. We would head up to the midline, go all the way up to the maximum, drop down to the midline once again, and once again hit the minimum at the very end. Now keep in mind, this is a wave which continues to occur. So as we begin to connect the dots in between these graphs, you will have to go ahead and curve the ends of them upward. Because keep in mind, it's not that they continue to extend down in a downward direction, right? They do not go downward. They have to turn upwards. Remember, the maximum is 2, the minimum is -2. So once you hit that minimum or maximum, it's going to go back in that opposite direction. Giving a straight arrow will cause the entire problem to be wrong. Let's go ahead and take a look at slide 12. In slide 12, we repeat the entire process all over again. We start off with our amplitude, which is going to be 2. Our period would be 2 pi over 1. or 2 pi. Our subinterval would be 2 pi divided by 4, or pi over 2. Our phase shift is negative c over b. Keep in mind, in this case, we do not have a c. The plus 1 that we see here is actually our d, or our midline. So in this case, we have 0 over 1, or 0 for our phase shift. Our midline in this case would be a positive 1. The range, remember, we grab our midline, we first subtract 2, which would leave us with negative 1, and 3 as our maximum. We're going to go ahead and draw our dotted line at our midline, which is a positive 1. We're also going to go ahead and label our maximum of 3 and minimum of negative 1. We do know that we're going to be starting the phase shift at 0, which means we will be remaining on that y-axis. Since the equation is positive, we will actually be starting at the maximum value, which is starting at that 3 marker. Now, our subinterval is pi over 2, so as we go marking each one of these, this would be pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Now, since we are already starting at the maximum, we know that our next point would be at the midline. Next point after that would be at the minimum. At 3 pi over 2, it would be at the midline again. And at 4 pi over 2, it would be at the maximum. We go ahead and connect the dots. In this case, remember, since we are already at the maximum, we would end up having to have it curl back down to show that it would continue working in a cycle all the way through. Let's go ahead and take a look at slide 13. In this case, we are seeing each one of our letters. We are seeing A, B, C, and D within this problem. Our amplitude for this problem would be 2. Our period would be 2 pi over B, or 2 pi over 2, which is pi. Our subinterval would be pi divided by 4. Our phase shift would be negative c, or pi, divided by b, which is over 2. Now, oftentimes we do want for our phase shift and our subintervals to have the same denominator. This makes it much easier for us to be able to graph. So in order for us to get pi over 2 to have the same denominator of 4, this would have to turn into 2 pi over 4. Our midline is our d, which is negative 1. We are going to subtract negative 1 minus 2, which is negative 3. And our maximum would be adding 2 to the negative 1, which would be 1. We go ahead, draw our dotted line at the midline. Draw our maximum, which is at 1. Our minimum, which is negative 3. In this case, our phase shift is going to be 2 pi over 4. Now, if we're going to go and work in increments of pi over 4, we would have to go ahead and work this as pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Now, once again, we still have the same period, which is a distance of pi. Since we are beginning with 2 pi over 4, first thing we're going to take a look at is our equation. And in this case, it is a positive equation, so we will start with the maximum, which is 1 at the 2 pi over 4. We would then drop down to our midline at 3 pi over 4, hit the minimum at 4 pi over 4, hit the minimum again at 5 pi over 4, and hit the maximum at 6 pi over 4. Keep in mind, we would connect the dots and we would show that, notice they would curve at the very maximum and curve back down to show continuation of the wave. Let's take a look at slide 13. In slide 13, here we have, once again, all 4 terms being shown. We have a -1 as our A, B as 1, C as a positive pi, and D as -3. Our amplitude in this case would be 1. Period would be 2 pi over B, which is 1 or 2 pi. Our subinterval is 2 pi over 4 or pi over 2. Our phase shift would be a -pi over 1 or -pi. Keep in mind, we want our phase shift and our subinterval to have the same denominator. In order to do that, we would write the -pi as a -2 pi over 2. Our next step would be our midline. Midline is D, which in this case would be -3. We go ahead and add and subtract 1 from -3. So if we were to subtract -3 minus 1, that would give us -4 as our minimum. And our maximum would be adding 1 to -3, which is -2. First thing we would go ahead and do is draw our midline at -3. From there, we're going to label out our maximum and minimum. In this case, maximum would be -2. Our minimum would be -4. We're also going to label out our subintervals at a distance of pi over 2, and we're going to start at a phase shift or horizontal shift of -2 pi over 2. So the easiest way to write this out, this would be our -2 pi over 2, -pi over 2, 0 pi over 2. This would be 2 pi over 2. Notice we are beginning with -2 pi over 2. Since this equation is negative, we will actually have our first dot on the minimum itself. At pi over 2, it would hit the midline. It would hit the maximum at 0 and -2. At pi over 2, it would hit the midline once again. And at 2 pi over 2, it would hit the minimum once again. We would go ahead, connect our dots, and notice it would curve back up towards the maximum. And this cycle would continue to occur. This right here would be exactly how each one of these cosine functions would be graphed. Highly suggest if you have any questions, please feel free to ask at any point.